Hey everybody, let's solve some logarithmic equations. I've got a involved one right here. We've got the log base 3 of x plus 6, and we're adding to it the log base 3 of x plus 4. And now all of that is equal to 1. And the first thing we're going to have to do is we're going to have to take these two logs and combine them together. And since there's addition between them, that means we're going to multiply the arguments. So I'm going to go ahead and do a little scratch work here. I'm going to take x plus 6, and I'm going to multiply it by x plus 4, x squared plus 10x plus 24. Okay, so that means we're going to have the log base 3 of x squared plus 10x plus 24, and that's going to be equal to 1. Now, the base here is 3, so that's going to be the base for our exponent. So this is going to be 3 to the log base 3 of x squared plus 10x plus 24, and all of that is equal to, once again, 3 to the first power. Here on the left-hand side, this is going to reduce, and we'll be left with just the expression inside the logarithm. X squared plus 10x plus 24 is equal to 3 to the first power, which is 3. Now, we're solving a quadratic, so we want to get it equal to 0. And then we're probably going to factor. So x squared plus 10x plus 21 is equal to 0. And indeed, this factors into x plus 7 times x plus 3, and that's equal to 0. So these values of x are -7 and -3. But are they in the domain? Let's take a look at our logarithms. We have the log base 3 of x plus 6. If I stick -7 in there, we would have the log base 3 of -7 plus 6, which is the log base 3 of -1. And, hey there calculator, can you tell me what the log of -1 is? Oh, it's not a real number. Since we're working with real numbers right now, that's not in our domain, and that's not one of our solutions. That means that our solution is the solution space -3. Since -3 plus 4 is 1, and -3 plus 6 is 3, -3 is in the domain. That's our solution. Let's take a look at solving another one of these examples. In this case, we have the log base 2 of x plus 2 minus the log base 2 of x minus 5, and that's equal to 3. This is base 2, so we can combine both of these. This is subtraction, so we're going to divide. We'll have the log base 2 of x plus 2 divided by the quantity x minus 5, and that's equal to 3. So we're going to use that 2 here as the base of our exponents. So this is going to be 2 to the log base 2 of x plus 2 over x minus 5, and that's equal to, let's see here, 2 to the third power. So over here, these are going to reduce, and let's write it a little closer to this equal sign. We'll be left with x plus 2 divided by x minus 5 is equal to 8. So we'll have x plus 2 times x minus 5, and I hope you guys remember how we solve these. It's going to be minus 8 is equal to 0, and then we're going to take that 8 give ourselves a little bit of space here. So minus 8. I'm going to take 8, I'm going to rewrite it as times x minus 5 over times x over x minus 5. Well, I'm going to multiply the top and bottom by x minus 5 so that I can combine these two fractions. This will be x plus 2, see here, minus 8x plus 40 divided by x minus 5, and that's equal to 0. Good. So minus 7x plus 42 divided by x minus 5 is equal to 0. Okay, so minus 7x plus 42 is equal to 0. Minus 7x is equal to a negative 42. So x is equal to 6. That's our answer. 6 plus 2 is greater than 0. 6 minus 5 is greater than 0. So that means it checks out. Our solution space is 6, and it checks out, and it's in the domain of both logarithms. Great. Join me next time where we'll do some more solving.